Welcome to part 4 of 5 of NIEM Advanced Technical Concepts. Now let's do a quick recap. Part 1 was kind of an introduction to the NIEM and NIEM conformance and things like that. Part 2 was an introduction, kind of a whirlwind introduction to XML and XML schema. Part 3 went into some detail on advanced XML schema and started to delve into how XML schema works in the context of the NIEM and talked about some of those differences. And now we're in part 4, which talks about NIEM-specific concepts that don't exist in XML schema itself, but NIEM-specific concepts and how those concepts are implemented via XML schema. Now in this section we're going to cover a lot of different things. We're going to talk about substitution groups, which is an XML schema thing, but used in a particular way in the NIEM. We're going to talk about code lists and how the NIEM does code lists. Code lists are very important. We're going to talk about the concept of roles and associations, which are ways in which the NIEM links objects together. We're going to talk about metadata in the NIEM. And then finally, we're going to talk about augmentation, which is a bit of an oddball topic, but we'll get to it when we get to it. Our first topic is substitution groups. Now, substitution groups are an XML schema thing that allow you to have one concept and represent it in different ways, even if those ways are structurally very different. The NIEM uses substitution groups in 3 main areas. First, it uses it in terms of implementing code tables within the NIEM to give them some flexibility. It also uses substitution groups heavily when it talks about dates and times, allowing you to represent dates and times in a number of different formats. And then finally, the NIEM has a concept called entities, where an entity can be either a person or an organization. In all of these instances, the idea is you have one conceptual idea, one semantic idea, and you have different ways structurally to represent it. In substitution groups, you have one element that represents the concept itself, and this is called the substitution group head. Then you have other elements that specify that group head as being basically the head of the group, something for which they can be substituted for. So that's the idea. You have a group head representing the concept, then you have the different ways of actually having that concept in XML, which can be substituted for the group head. There are 2 types of substitution groups. In one of the types, that substitution group head has an attribute called abstract, which is set to true. What this means is that without having a type, it can't appear in the instance document. You are required then to substitute it by one of the members of the group. So the head element is just there to represent that there's the concept, but the only way to actually represent the concept in an instance document is to substitute that group head with one of the group members that actually represents the concept in some concrete way. Now these are called explicit substitution groups because the head element is marked as abstract, it has no typing, it's explicit that this is the head of a substitution group, it can't do anything else but be replaced by one of the group members. The other type, the head element actually has a type. The other type has a type. It's not explicitly marked as abstract. In other words, that head element can hold information, can be in the instance document. In this case, this is called an implied substitution group because by just looking at the head, you can't tell that it's the head of a substitution group. In these cases, the substitution is optional. You can have the head element there with whatever data or elements its typing allows, or it could be substituted with one of the group members. Now, one caveat to all this is that the group members must be the same sort of type. What I mean by this is they either need to be the same type as the head element, or they need to be of a type derived from the type of the head element. A quick way of saying it is they have to hold the same kind of stuff. Basically, if they hold the same kind of stuff, then they can be part of the substitution group and can optionally substitute for the head element. With explicit substitution groups, remember the group head element has an attribute abstract, which is set equal to true. It doesn't have a type, it's set to abstract. This makes substitution required. The head cannot appear in the instance document, but it instead has to be substituted by one of the group elements. So the heads act solely as placeholders for the substitute elements. They just represent the concept, and then they're replaced by one of the substitution group members. Now, it's important to know that the group members identify their head element, not vice versa. We're going to look at the XML in just a second here, but when we do, you'll see that it's the group member elements that say they're part of a substitution group, not the head element. With implied substitution groups, the group heads are not defined as abstract. They actually have some sort of type defining what kind of things they hold, be that other elements or be that chunks of data. In these cases, substitution is optional. The head can contain actual content, or the head can be substituted by a group member. Thus, substitution group heads in an implied substitution group can appear in the instance document. Remember that group members must be of the same type as the head or of a type derived from it. They have to hold the same kind of stuff is the general idea here. One major area in which the NIEM uses substitution groups is in implementing code tables. Now, code tables are great for data quality. You've got a limited number of options, a limited number of choices for the data that can go in as a valid code. And that's great. That helps constrain the information you're going to get, lets you prepare better for getting that information. It helps data quality. But not everybody is able to support code tables. You know, you'll have jurisdictions where one jurisdiction has a code table for something and another jurisdiction just uses some sort of text field, and that won't match up with the codes in the first code table. Well, what the NIEM does to handle this is that each code table, each concept that's implemented as a code table is actually done as a substitution group. The concept itself is the group head. The concept then must be substituted with either a version that is a code table and has a lot of code table entries, or a version that's just a plain old string. So that's how code tables are handled via substitution groups in the NIEM. There is a substitution group head to represent the concept, and then that is replaced by either a code table version or a text version. And this is true of, I think, every code table in the NIEM. I'm not personally aware of any cases where the code table does not also have a textual counterpart for the sake of flexibility. So here's some actual XML, and this is taken from the CIFAS domain, the Children, Youth, and Family Services domain. And it is the person other kin association category. Basically, it describes the kinship or close personal relationship between two people. Now at the top, you'll see the substitution group head. You'll see that's person other kin association category. It represents the concept of a person other kin association category. And you'll see abstract equals true. That tells us that yes, this is the head of a substitution group. It's an explicit substitution group. Right below that, we see the element that represents the code table version. So that's the code table version, person other kin association category code. Now right under that name, you'll see substitution group equals CIFAS : person other kin association category. In other words, it's saying, hey, I am a member of a substitution group, and the head of my substitution group is person other kin association category, that abstract element right above it. So that's how we know that this code table element replaces person other kin association category. Now right below that, you'll see the text version, person other kin association category text, and its type is NIEM course text type. It's a string. It also has a substitution group set equal to CIFAS person other kin association category. Again, that tells us that this text string can substitute person other kin association category. The end result is we have the concept of person other kin association category, but the ability to represent it as either a code table entry or as just a text string. Let's take a look at that. Here are two snippets of an instance document that illustrate what we've just done. The first one is the code version. You'll see person other kin association, that's the parent object around this category code. We're going to talk more about associations later in this presentation. The important part here is the person other kin association category code with a code entry of sister. Now if you go and actually look at the entries for that code table, sister is one of them, brother is in there. There's a whole bunch of kind of quote-unquote typical kin associations. But what if you have one that isn't in the code? Or what if you just don't have these things as code tables? You want to have it as a text string. Well, that's the bottom half of the screen, where we have the same thing, only this time inside of person other kin association. We have person other kin association category text with value in there of weird uncle. Now, I tell you now, there is no weird uncle code in that category code table. And yes, I'm usually the weird uncle. Not creepy uncle, weird uncle. So here we have the ability to represent the concept of a person other kin association category, but to do it either as a code table or do it as just a plain old text string. Another area in which the NIEM uses substitution groups are in something called entities. Now, what entities are about is that some concepts can be either a person or an organization. You'll see these a lot. One of them is a party to a case. You can sue a person or you can sue an organization. You can do either one. Now, arguably, these would be better handled with roles. And we'll talk about roles later in this one presentation as well. But that's not how the NIEM does some of these. The NIEM uses a term called entity. An entity is something that can be either a person or an organization. Let's take a look at how this actually works. So here's an example of how the NIEM represents this concept of entities using substitution groups. In this schema example, we'll see it starts with a complex type called entity type. And if you look way at the bottom, the very last line, we have a custodial entity of entity type. A custodial entity would be a person or organization that acts in a custodial fashion. So we've got this entity type. Let's look at what it is. Well, its base is complex object type. So it's really just an empty container to which we add one thing, an entity representation. Well, what is an entity representation? Well, we'll look again near the bottom of our snippet, and we'll see that entity representation is substitution group head. How do we know this? Because abstract is equal to true. It has no typing. It has to be replaced with something else. It can't show up in an instance document. So it's the head of an explicit substitution group. So what sort of things can it be replaced by? Well, we'll look at the first one here, entity organization reference. You'll see it has a substitution group equal to entity representation, which means it can be substituted for it. It can go inside of that custodial entity. And it's a reference type. It's a reference. It's a pointer that points to an organization that's acting as the custodial entity. Right below that is entity organization of organization type. This is an actual organization object holding all the things an organization would hold that sits there inside of the custodial entity. So it can hold a reference to an organization or an organization itself. Following that is an entity person reference. Again, this is another reference, only this time this one points to a person object. So we can see that the custodial entity can contain pointers to an organization itself, or a pointer to a person. And then finally, there is the entity person of person type. So it holds all the things a person object holds. And it too, you can see its substitution group equals entity representation. It too can be replaced for that entity representation that's inside of the custodial entity. So the custodial entity, the concept of a custodial entity, can hold any of these four objects. It can hold organizations, people, or pointers to either organizations or people. And this is how the NIEM handles this idea of an entity, something that can be either a person or an organization. And you'll see other entities throughout the NIEM when you use the various search and exploration tools for the NIEM. You'll see a lot of different entities in the NIEM. So here are some snippets of XML from a fictional instance document showing the four different ways that you could represent the concept of an entity. So in the upper left, we have the custodial entity holding the entity organization reference with a ref attribute pointing to some ID, and then below that an organization with that ID, so the reference is pointing to it, and that organization has some organization name, because that's one of the things organizations have. Directly below that, in the lower left, is the version of an organization-based entity, only this time the whole organization object is inside of the entity object. So we have custodial entity, and inside of that we have an entity organization, and inside of that we have the organization name. Now on the upper right, we have the person version starting out. We have custodial entity. Inside of there we have the actual entity person. Now I did the reference at the bottom simply because it fits on the slide better. So we have the actual entity person there. Inside of entity person is a person name. That's what people have. And inside of that is a person full name, and then there'd be actually some name there. At the bottom right is the final way of showing it, and that's using the person reference. So custodial entity, inside of that, the entity person reference with some reference ID, ID 0003, and then below that, the person object with that same ID number, so the reference is pointing to it, and then inside of that person object is the name, and inside of that is the person full name, and inside of that is the actual text of the name. So 4 different ways to represent the concept of a custodial entity. 2 of them representing it as an organization, and 2 representing it as a person.